Good day, students. This is Sir JM. This video will show you another method for implicit differentiation. The procedure is almost similar from the first video about implicit differentiation. I will be using the same examples and practice exercises from the first video, and you will notice that same answers will be obtained. So again, this video is about implicit differentiation. Implicit differentiation is the process of finding the derivative of dependent variable in an implicit function by differentiating each term separately, by expressing the derivative of the dependent variable as a symbol, and by solving the resulting expression for the symbol. Before we start, so remember this for implicit differentiation. Let's say we have x. If we will get the derivative of x, dx will simply be dx. Let's say we have x squared. The derivative of x squared is 2x dx. Okay? We will use this in implicit differentiation in the items that we will solve later. Let's say we have x cubed. The derivative of x cubed is 3x squared dx. Let's say y. The derivative of y is simply dy. The derivative of y squared is 2y dy. The derivative of y cubed is, correct, 3y squared dy. Let's say we have xy, the derivative of xy. So in this case, we will apply the product rule. So this will become x dy plus y dx. If you're going to encounter x over y, so the derivative of x over y, you will apply the quotient rule. So it will be y dx minus x dy all over y squared. If you're going to have the derivative of 1 over x, so you will apply the principle of the derivative of the reciprocal. So this will be negative dx over x squared. And if you have the derivative of 1 over y, it is simply negative dy over y squared. Take note, let's say you're going to get the derivative of 2x. So the derivative of 2x is 2. But in this case, you will write 2 dx. So for example, you will be getting the derivative of 3y. So it will be 3 dy. Okay, is it clear? Example number 1. Find the derivative of xy equals x plus y. So the first thing that we will do is to get the derivative of each terms. So this will become derivative of xy equals dx plus dy. So like what I've said before, the process is almost similar from our first video. So here, we will apply the product rule. So it will become x dy plus y dx equals dx plus dy. So write the terms or the like terms together. So we are going to write the terms with dy together and the terms with dx together. The terms with dy will be in the left side of the equation. The terms with dx will be on the right side of the equation. Why? Because our final answer will be, or that in the left side of our final answer, we're going to have dy over dx. Okay? So next is let us factor out dy and dx. So this will become dx times x minus 1 equals dx, or I'm sorry, dy times x minus 1 equals dx times 1 minus y. Okay? Then divide both sides by dx and divide both sides by x minus 1. So this will become dy over dx equals 1 minus y over or all over x minus 1. Okay, so to be short, so as you can see, dx was divided here. It became dy over dx, and x minus 1 was divided here. So that's why it became 1 minus y all over x minus 1. Again, our final answer is dy over dx equals 1 minus y all over x minus 1. You get it? Okay, example number 2. Find the derivative of x squared minus y squared minus x plus 1 equals 0. First thing to do is to get the derivative of each term. So this will become dx squared minus dy squared minus dx plus derivative of 1 equals derivative of 0. So this will become 2x dx minus 2y dy minus dx plus 0 equals 0. Then, write the terms with dy on the left side of the equation. Write the terms or transpose the terms with dx in the right side of the equation. So this will become negative 2y dy equals negative 2x dx plus dx. So we can multiply or divide both sides of the equation by negative 1. So it will become 2y dy equals 2x dx minus dx. And then factor out dy and dx. So it will become dy times 2y equals dx times 2x minus 1. And then, so you know what to do. Divide dx here. Dx will become a denominator on the left side of the equation. Then 2y will become a denominator on the right side of the equation. It is actually similar to what you call cross multiplication. So just imagine that there's an imaginary over 1 here, over 1 here. So multiply dx to 1 here and multiply 2y to 1 here. So it will become dy over dx equals 2x minus 1 all over 2y. That's our final answer. Okay? So as you can see, implicit differentiation is a combination of your knowledge about the different rules in differentiation and your skills in algebra. So take note that skills in algebra is very important in all mathematics subjects. Now let's proceed to the third example. Example number 3. Find the derivative of square root of x plus y plus 1 equals x squared minus y squared. Get the derivative of each terms. Okay, so since this is square root of x plus y, let us write it into rational exponent. Okay, so I know you already understand what happened here. So in this first term, we are going to apply the general power rule. So the derivative of x plus y raised to 1/2 is 1/2 times x plus y raised to negative 1/2 times dx plus dy. Dx plus dy is the derivative of x plus y. Then derivative of 1 is 0. The derivative of x squared is 2x dx. The derivative of y squared is 2y dy. So that's minus 2y dy. Okay? Do not forget the sign. Then, since it is negative here, we can write this as a denominator. So this will become dx plus dy all over 2 times x plus y raised to 1/2 equals 2x dx minus 2y dy. So let us change this into radical form. So this will become dx plus dy all over 2 square root of x plus y equals 2x dx minus 2y dy. And then we can split it, so it will become two terms, dx over 2 square root of x plus y plus dy over 2 square root of x plus y equals 2x dx minus 2y dy. And like what we're doing from the previous examples, write the terms with dy together, write the terms with dx together. The terms with dy will be on the left side of the equation, and the terms with dx will be on the right side of the equation. Okay, that's why it will become dy over 2 square root of x plus y plus 2y dy equals 2x dx minus dx over 2 square root of x plus y. So please be careful when you are performing transposition. Take note of the signs, okay? Make sure the signs will be correct. And then in this case, we will factor out dy. So this will become dy times 1 over 2 square root of x plus y plus 2y equals dx times 2x minus 1 over 2 square root of x plus y. Okay, so these terms we're going to add. So we are going to apply addition of fractions. Okay, so another application of your skills in algebra. So this will become dy times 1 plus 4y square root times square root of x plus y all over 2 square root of x plus y equals dx times 4x times square root of x plus y minus 1 all over 2 times square root of x plus y. For if you are wondering what happened, so here, so as you can see, the denominator or the least common denominator will be 2 times square root of x plus y. Okay, and then this 2y will just be multiplied to this denominator. Kasi there's an imaginary one here. So if you're going to divide 2 times square root of x plus y divided by 1, so the result will be 2 times square root of x plus y times 2y. So this will be the result, 4y square root of x plus y. So same with what happened here. Okay, and then so this will become dy over dx equals 4x times square root of x plus y minus 1 all over 2 times square root of x plus y divided by this, which is 1 plus 4y times square root of x plus y all over 2 times square root of x plus y. So remember, we are dividing rational expression. So just change the operation into multiplication, then express this or the divisor in its reciprocal. That's why it will become multiplication. Okay, so we have common terms here in the numerator and the denominator. It will be cancelled. Okay, so the answer will be dy over dx equals 4x square root of x plus y minus 1 all over 4y times square root of x plus y plus 1. Okay, so as you can see, I just wrote 4y times square root of x plus y first, so that it will become it will look better. Okay, example number 4, find the derivative of 5y minus 2x plus y cubed equals x squared y. So get the derivative of each terms. So the derivative of 5y is 5 dy, the derivative of 2x is 2dx. Not forget the sign. The derivative of y cubed is 3y squared dy. The derivative of x squared y is x squared dy plus y times 2x dx. So this was obtained because of the application of the product rule. Okay, so y times 2x dx will be simply 2x y dx. Okay, and then the terms with dy and will be on the left side of the equation. The terms with dx will be on the right side of the equation. This is what's going to happen. We're going to have 5 dy plus 3y squared dy minus x squared dy equals 2xy dx plus 2dx. And then factor out dy and dx. So it will become dy times 5 plus 3y squared minus x squared equals dx times 2xy plus 2. So this will become dy over dx equals 2xy plus 2 all over 5 plus 3y squared minus x squared. So this could be our final answer. Now it's okay if your terms will be interchanged. Let's say your answer is dy over dx equals 2 plus 2xy all over 3y squared plus 5 minus x squared. That's okay. So the sequence of the terms could be different based on your solution, but make sure that the sign is still correct. Okay. So for practice exercises, find the derivative of the following. Number 1, 2y plus 5x plus x to the 4 equals x cubed y squared. Number 2, x squared minus y squared plus xy equals x squared y. So I'm going to give you 2 minutes to answer this. If you need more time, you may pause the video. Then I will show you the solution and then kindly check if your answer is correct. One minute left. Thirty seconds remaining. Like what I've said, you may pause the video if you need more time. Time's up. I hope you were able to get the correct answer. The answer for number 1 is dy over dx equals 3x squared y squared minus 4x cubed minus 5 all over 2 minus 2x cubed y. For number 2, the answer will be dy over dx equals 2xy minus 2x minus y all over x minus 2y minus x squared. Okay, check your answer. If it is correct, I hope you get the correct answer. So let us see if we have the same solution here. For number 1, 2y plus 5x plus x to the 4 equals x cubed y squared. get the derivative of each terms. So this will become 2dy plus 5dx plus 4x cubed dx equals x cubed times 2y dy plus y squared times 3x squared dx. Okay, so the right side of the equation will just be 2x cubed y dy plus 3x squared y squared dx. Okay, and then our favorite part, writing the like terms together. The terms with dy on the left side of the equation, the terms with dx on the right side of the equation. And then factor out dy and dx. So this will become dy times 2 minus 2x cubed y equals dx times 3x squared y squared minus 4x cubed minus 5. Okay, so this will be dy over dx equals 3x squared y squared minus 4x cubed minus 5 all over 2 minus 2x cubed y. So this could be our final answer. Okay, so from our first video, we have y prime here. In this video, we have dy over dx. So the solution, the process is almost the same. If we are doing the procedure correctly, we will be getting the correct answer. For number 2, x squared minus y squared plus xy equals x squared y. So get the derivative of each term. So this will become x dx minus 2y dy plus x dy plus y dx equals x squared dy plus y times 2x dx. So this will be 2xy dx, okay? And then write the terms where they belong, where they should belong, okay? So this will become x dy minus 2y dy minus x squared dy equals 2xy dx plus 2x dx minus y dx. Then factor out dy and dx. So this gives me a lot of satisfaction if I'm able to factor out dy and dx. Okay, so this will become dy times x minus 2y minus x squared equals dx times 2xy plus 2x minus y. And then for the finishing touch, this will become dy over dx equals 2xy minus 2x minus y all over x minus 2y minus x squared. And this is already an acceptable final answer. Okay? So I hope you are enjoying implicit differentiation. So implicit differentiation, I think this is a good practice for differential equations. In college, you're going to have that subject, DE, or differential equation. So this is a good practice. You will be able to use this, hopefully. Okay, more items for practice exercises. Find the derivative of the following. Number 3, 1 over x plus 1 over y equals xy. Number 4, square root of x plus y equals xy. Again, I will be giving you 2 minutes to answer this. You may pause the video if you want or if you need more time in answering these exercises. Okay, good luck. I hope you get the correct answer. Time's up. I hope you get the correct answer. For number 3, the answer will be dy over dx equals negative y squared times x squared y plus 1 all over x squared times 1 plus xy squared. For number 4, the answer will be dy over dx equals 2y square root of x minus 1 all over 2 square root of x times 1 minus x. Here's the solution for number 3. 1 over x plus 1 over y equals xy. Get the derivative of each terms. So we're going to have negative dx over x squared minus dy over y squared equals x dy plus y dx. So as you can see in 1 over x and 1 over y, the concept of derivative of a reciprocal was applied. So in the right side of the equation, obviously, product rule was applied. Okay? And then write the terms with dy and dx together. Dy on the left side of the equation, dx on the right side of the equation. Oh, I am repeating myself. Okay? So negative dy over y squared minus x dy equals y dx plus dx over x squared. And then this will become dy over y squared plus x dy equals negative y dx minus dx over x squared. Okay? So what happened? We divide or multiply both sides of the equation by negative 1. So factor out dy and dx. This will be 1, or I'm sorry, dy times 1 over y squared plus x equals negative dx times y minus 1 over x squared. So before we proceed to dy over dx, let us combine this term for the terms to be a single fraction. Apply your skills in algebra. So this will become dy times 1 plus xy squared all over y squared equals negative dx times x squared y minus 1 all over x squared. So do not ask me what happened, okay? You should know that already. And then for our most favorite part in implicit differentiation, writing the final answer. So this will become dy over dx equals negative x squared y minus 1 all over x squared divided by 1 plus xy squared all over y squared. Unfortunately, this is not yet our final answer. So since we have division here, this will become multiplication, and then the divisor will be expressed in its reciprocal. So this will become dy over dx equals negative x squared y minus 1 all over x squared times y squared over 1 plus xy squared. And then this will be dy over dx equals negative y squared times x squared y minus 1 all over x squared times 1 plus xy squared. Okay? So let us make our final answer more handsome. So this will be dy over dx equals negative y squared times x squared y plus 1 all over x squared times x y squared plus 1. So this is our final answer. But actually, this is already an acceptable final answer. I like it better this way. For number 4, we have square root of x plus y equals xy. So get the derivative of each term. So this will become dx over 2 square root of x plus dy equals x dy plus y dx. So as you can see here, a little bit of a shortcut. Okay? You know what to do here for sure. So this will become dy minus x dy equals y dx minus dx over 2 square root of x. Okay? Then factor out dy and dx. So this will become dy times 1 minus x equals dx times y minus 1 over 2 square root of x. Then, okay, so we express it as a single fraction. So this will become dy times 1 minus x equals dx times 2y square root of x minus 1 all over 2 square root of x, and then this will become dy over dx equals 2y square root of x minus 1 all over 2 square root of x divided by 1 minus x. So again, there's division involved, so change the operation into multiplication, express the divisor into its reciprocal. The reciprocal of 1 minus x is 1 over 1 minus x. Okay, so multiply the numerators, multiply the denominators. So our answer will be dy over dx equals 2y square root of x minus 1 all over 2 square root of x times 1 minus x. Okay, this is our final answer. So I hope you enjoyed solving or performing implicit differentiation. Again, this is Sir JM. Always remember, math is fun. So together, let's do it right, okay? Stay sharp and stay bright. See you next time.